Good morning. We're going to be doing a review of right triangle trigonometry that you may remember from your geometry class, where we used the acronym SOHCAHTOA to remember how to find sine, cosine, and tangent. If we remember, our sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Let's take a look at how that works in terms of our right triangle that we have here. We have a right triangle, triangle ACB with right angle at C. And the tangent of an angle, in this case it would be either A or B, would be the leg opposite the angle or the leg adjacent. So if we want to do this in terms of angle A here as we're looking at it, so we'll call that angle A. In terms of angle A, the opposite leg is side labeled little a, and the adjacent is B. So this would be A over B. For the sine of that same angle, and we're going to use angle A as our theta, we're going to have the opposite over the hypotenuse. So we have side A over C. So A over C. For the cosine of that angle, it's the adjacent over the hypotenuse. If this is our angle we're focusing on, the leg next to it is leg labeled B, and the hypotenuse is C. So that's B over C. Okay, we also have three other functions, which are called the cofunctions. We have the cotangent, and the cotangent is just a reciprocal of the tangent. It's the adjacent over the opposite. So again, if we look at angle A, we're going to have the adjacent over the opposite, so B over A. For cosecant, it's the reciprocal of the sine, so hypotenuse over opposite, so C over A. And for the secant, hypotenuse over opposite, so, over adjacent. Gotta fix that note sheet. So that's going to be C over B. Alright, so on each one of these examples that we're going to do here, we're going to write a ratio for the sine of C, or the indicated ratio. So the sine of C is our angle here, and our sine is opposite over hypotenuse, so the sine ratio is 30 over 34, and we always like to reduce that, so that's 15 over 17. On number 2, we want the cosine of angle A, so the cosine is the adjacent over the hypotenuse. And so we have here the cosine just happens to be also 30 over 34 in a different triangle there. Okay, on number 3, our next one, number 3, we want the tangent of angle X, and this time instead of writing it just as a fraction, we want to round it to the 10,000ths place. So here's angle X, tangent is opposite over adjacent. So X is equal to 12 over 9, and if we take 12 over 9 and write it as a decimal, we get 1.3333. This is our thousandths place, so I want to round it to that place. So 1.333. Okay, and our next one, we want the cosine of angle C. Cosine again is adjacent over hypotenuse. So we're going to do 21 over 29. And again, we're going to write it as a decimal. And that is approximately equal to 0.7241. Here's our thousandths place. So 0.724 is to this thousandths place. We can find the value of angles. We can find the value of angles if we know the trigonometric ratio of that angle. So we can use the inverse trigonometric functions on our calculators. It says look for sine inverse, cos inverse, and tan inverse. I'm going to show you my TI-84, and here is our sine function, and the second function, which is the blue key, is sine inverse, and then we have cos inverse and tan inverse. So let's go ahead then and find the measure of angle C if we know that sine C is equal to 5150. So we know what that ratio is. We're going to do sine inverse, and I'm going to show you how that works. Here's our sine button right here. It's the second function sine. I'm going to write the ratio, and I get about 31 degrees on that. Okay, so we're going to do that again on each of these other ones. We want to find each angle measure, and we're going to round it to the nearest degree. So if we have the cosine is 0.7660, I'm going to go here to go second cosine and 0.7660, and I get 40 degrees. So this one is 40 degrees. And our next one is the tangent of angle C. So I'm going to do tan inverse of 1.881. Tan inverse 1.881. And I get 62 degrees. And our last one here says the sine of A, so I'm going to use sine inverse, so second function sine, 0.9563, and I get 73 degrees. Okay, and in number 8, our next example, we want to find the measure of the indicated angle to the nearest degree. So we have a triangle. We want to find what this measure is. So as I look at this angle, we have the opposite and the adjacent, and I know that the tangent of an angle, we'll call it A, is equal to the opposite leg over to the adjacent leg. So in this case, it's 9/21. And I've written that right here. So in order to find A, I'm going to do the tan inverse of 9/21. And we're going to do that using our calculator. So second tan inverse of 9/21. And I get angle A is, to the nearest degree, 23 degrees. And that's our quick review for right triangle trigonometry.